distance intervals. And the first thing you need to know are a couple of vocabulary things. A point estimator is some kind of statistic that provides some kind of estimation of a population parameter. For example, a mean would be a point estimator, a median, an IQR, something that talks about some kind of information about your population. Down below, an example here. Oh, sorry, point estimate is an estimate of a population parameter. Best guess, usually a mean or a median, not always, but usually. In each of the following settings, we're going to try and figure out what point estimator would be good based on what they give us for information. So in part A, they talk about some makers of golf balls want to estimate the median. So right away in this information, I see this word median. So in my head, I'm thinking that's going to be the point estimator. The median distance that new balls travel when hit by a mechanical driver. They select 10 samples, random that is, and measure the distance that each of the balls travels after being hit by this driver, and here are the distances. So what do we think the point estimator is going to be? The median, because they say median in the words. And if you were to line these all up from small to big, I'm pretty sure that you would find out that the median is 285. So that would be your point estimator. Something that's kind of, I think for us would be common sense. They talk about a median, so you're looking at a median. In the second part, part B, they talk about the variability of the distance traveled. So when they talk about variability, when we talk about variability, there's different things that we can talk about. We can talk about the standard deviation, we can talk about the variance, we can talk about the range, the spread. In this particular case here, they mention again something else. They mention interquartile range. So our point estimator here about what's going on with the variability is we would talk about the IQR. So in this particular sample, our IQR would be 287 minus 284, which is a total of 3 yards. And this was Q3. If you line them up from small to big and you look at the IQR, this is Q1. So look for the keywords in the sentence as they ask the question of what they want. So they tell you interquartile range, you do interquartile range. If they tell you median, you do median. And in part C, the math department wants to know the proportion of students that own its own graphing calculator. So they take a random sample of 100 students and find that 28 own a calculator. So if they tell you that 28 out of 100 own it, my guess would be that they're talking about some kind of proportion. So I would say the point estimator in this case, I would use a proportion, and that proportion of our sample was 28 out of 100. You for sure could write that as 0.28 as your point estimator out of our sample. Okay, so in this next example here, we're going to talk about some mystery mean. So Mr. Bartz stores a mystery mean in his calculator, mu. And he tells the calculator to choose a simple random sample of 16 observations from a normal population. So clue already, they tell me that something's going to be normal. So now we can do some statistics with it. It has the mean m and a standard deviation of 20. And we want to find out what's the sample mean of those 16 samples. So in his calculator, he types in some stuff to find a sample. Remember, he's already hidden this mean in there. We don't know what it is. And out pops the following pieces of information. So I look at these numbers. Here's what he pops out of the calculator. 234.33, 230.84, 246.85, 239.49, 243.84, 240.10, 240.92, 240.40, 250.75, and 240.75. 0.94. And what I would pose to you is, if you were looking at all those numbers, and you had to guess what the mystery mean was, what would you guess? What's it? 240, somewhere around 240. We don't know exactly what it is. These are samples that he took. We don't know it, but if we had to guess, 240 would be, based on the numbers that we see here, probably a pretty decent guess. So we could guess, and we don't know if we're right or not, but we could guess 240. And we'd probably be very close, based on what we see on the samples. Remember, we talked about yesterday that if we have n greater than or equal to 30, we're really pretty confident that we know what's going on no matter what the population distribution looks like, because 30 is big enough to make sure that we're approximately normal. Anyways, and if they tell us that the population is normal, then the sample size doesn't even matter. Okay, so 240 is probably a pretty good guess. Somebody had a question? No? Okay. Okay, so how do we go about this stuff? A confidence interval is giving an interval where we think this true parameter, in this case a mean, lies within. And a confidence interval has two parts. One is the estimate, and two is the margin of error. So we guessed 240, but we could be off, and so it's going to be plus or minus some kind of margin of error. The margin of error is going to tell us how close our estimate is to the true proportion. And a confidence interval is going to give us the overall success, and they abbreviate confidence interval CI, so if you want to in the future do that, feel free to do that. Gives us a success rate of the method for calculating this interval. That is the confidence interval percentage, so oftentimes we use 95% in statistics. So a 95% confidence interval of all possible samples, the method would yield an interval that capped in 95% of all of our samples. We would find the true mean in there somewhere. So 95% of the time we'd be correct in guessing. Here's how it works. Down below you see a picture. And in this picture of our distribution, we have a population. And we have a mean that we know is the true mean. In our example, we said that our standard deviation was 20. We take a sample of 16, we get a mean of 240.79. We take another sample of 16, we get 246. We take another sample, we get 248. What happens? When we take this distribution, we see that we get all these different sample means. Just like we talked about before, we had that candy jar and we're popping all these different numbers. And then what we don't know is the true population mean. But if we look under that distribution curve of all of our samples, 95% of them that we took would have the true mean inside. So we have that mean that we estimate, and then if we look at 95% of those samples that we took, 95% of them would have the true mean inside of that mean plus or minus some kind of margin of error. That's what it's talking about. As we go along and we look at this sampling, if we look at our previous example, we talked about that our standard deviation was 20, and then we had a sample size of 16. So we know that when we talk about our standard deviation, oh my goodness, sorry. When we talk about our standard deviation of our samples, we know that we take the standard deviation and we divide it by the square root of n. So we had 20 divided by our sample size was 16, and that gives us 5. So you might have seen before when we were talking about, I don't know where they had it, but I think maybe on the previous page they had 5 for that. And then down below here, we're talking about the margin of error. So when we have this sample, sorry, I was just looking back at that. So based on what they're talking about here, they talk about margin of error. So they had the 3 different means that they calculated, and they do plus or minus their margin. And what they're saying is whenever they take those, plus or minus the margin, 95% of these intervals that we talk about will have the true mean inside of them. And we're actually going to go through and do one so you can kind of see how it works. There's a certain phrase that you use all the time, and we're going to talk about that in just a little bit too. What this is talking about is as you take your samples here down below, what you'll notice is every single time you take a sample, these dots are indicating the mean that you calculated in your sample. So we grab the sample, and as you saw in the previous slides, we had 240, 250, 239, whatever. All of these dots are indicating here what that mean was. The arrows in either direction that you see are the error that you could be off by, so that in this slide, the plus or minus 10. So each of these dots are from our samples. Each of the arrows are the error that we could have. And the line in the middle that's vertical is the true mean that we're trying to guess. And what you'll see is, if you look at all of these dots, and you look at the true mean, and you look at the distribution that we have, 95% of these dots fall somewhere where the true mean would be located if you include the margin of error. There is a dot far off to the right here that does not capture it. So if you remember the 68-95 rule, 99.7, inside of here we have 68% of our material, and then inside of the next band we have 95% of our material. And the one that's outside the orange, the dot that's far to the right, is a mean that missed when we took our sample. So 95% of those samples that we take will have the mean when we include the error. That's what a confidence interval is saying. So down below here, the center, which is x bar, is marked by these dots. The distance is the margin of error. Those are the arrows I was talking about. And we'll notice that 24 out of the 25 samples that we took, in our case it's actually 96%, had the true mean in it. When you interpret confidence intervals, there are two different things that they talk about. They talk about a confidence level, that's our 95%, and they talk about the confidence interval. That's whatever your mean is plus or minus your margin of error. So one of the things that we want to do in our class is you want to memorize this following phrase. This is something that you will use all the time. We are whatever percent you want to talk about. In our case, 95% confident that the interval from, and then you go from the low to the high of whatever you're talking about, captures the actual value of the, and then you name whatever you're talking about, the true mean of golf ball distances or whatever it is that you're talking about. Again, put it in the context. Caroline? So some examples will kind of put it in perspective maybe.